Hi, everyone. Thank you so much for your patience. But as you might have known, we experienced some technical issues. So, can I get a round of applause for our tech support who is working here tirelessly to get it running? Wonderful. So, without further ado, we have another familiar face here with us. Max Grünfelder is here with us again. And to not waste any more of your time, this is your stage.
Thank you. Thanks, everybody, for the patience and for joining the next session of our CAP community organization, or from us from the Advanced Financial Closing team. As we already said, that Advanced Financial Closing is an application doing financial close. So that means by the nature of the product, we have some really hard requirements based on we need to do financial close in a packed period of time. So we have around 7 to 10 days where large companies are doing their financial close. So we need to have a really resilient application. We need to focus on load balancing. We need to avoid something that is called noisy neighbors, because you don't want to have, if you have a CAP multi-tenant application, you don't want to have that the company A can really slow down the financial close of company B. So you really need to make sure that things like that are taken care of, and our aim is, with the plugins we have in the CAP community, that complexity and all of the pitfalls that come with that are taken away from the developers, that they can really focus on writing business code, doing what's important, and that is bringing value to the customers. And that is what we try with CAP community event queue. The event queue is a framework built on CAP as a plugin, hooks into the application, and then allows you to ingest a lot of load that comes maybe from the UI, maybe through an API, takes in the load, separates it by customers, and then works on it gracefully. That means that each and every event, that can be, for example, a notification, but also some heavy calculation stuff or communication to any arbitrary system, taken in, that event has a certain load that puts on an application instance, and then the package makes sure that the load each and every application instance can take is never exceeded. And if the load is, for example, you have 4 application instances, the application load is full, then the load is queued and then processed and picked up as soon as resources are available. And also takes care that not one tenant can take up all the load that is available, so that it's really shared and equally distributed through the tenants and over the application instance. What we do support and have is ad hoc events. It's something that happens maybe based on an UI request, maybe based on an API request, but it's not something that happens regularly. For that, we have periodic events. For example, you want to do a DB check, or you want to do a consistency check that runs for each and every tenant, every hour or every minute. And then you can really have that with few lines of code, have an event handler that is being executed for each and every tenant, respecting the load on the application instances, and trying to keep the frequency, for example, that 1 hour frequency. And what we saw in the earlier presentation, where we take in load, store it on the database, and then free up the UI instantly, is a really pattern we learned over the last years, that this feels good for the users, that you can put your load on the application, the application takes care of it, because it's transactional safe, stored on the database, and you can keep on going, working on the UI, switching to a different application, and eventually it will be done. And that's what we do with that asynchronous processing. Then we hook in WebSockets to inform the user that something is done. We send out email notifications or Fury notifications, whatever. And with the CAP plugin support and with CDS Outbox approach, it's even easier to implement event handlers. And I will show that in a demo. We'll see how much time we have left because of the technical issues. I brought some typical use case I want to show real quick. And that's something typical from our application. So with the event queue, we have the possibility, as everything is event, we can also build up job chains that are indeed transactional safe, because one event inserts with the main transaction the next event, with that ensuring transactional safety, and with that building up job chains. And it doesn't matter if we have that job chain, user schedule something on the UI, we do some calculation stuff, we poll for results. If something is finished, we send notifications, then we poll again, and then maybe schedule next job. So this is a long chain. And between things can happen, right? So the backend might crash. Maybe your instance is being replaced by Cloud Foundry or by Kubernetes. So the instance is being restarted. Maybe deployment happens because you do frequent deployments. So all of that things can happen, but you have decoupled processes, but you want to have those processes transactional safe. So that means you cannot just send out a notification within the process. You want to commit it on the database and only want to send out that notification if the real business logic succeeds. And business logic succeeds means often committing the main transaction, and that's what the event queue is doing and hooking in. So I brought a small example. This is it's a plain CAP project with one application service is a process service, having a closing task that is being processed during financial close, has a bound action process that task. And then we have what we call facet. Those are internal CAP services. We want to send email notifications like I showed in the process graph. And we have a task service. I already implemented that task service. And the task service, if you create a task, you want to eventually process that task, do some logging. Processing the task takes some time. And when the process is finished, you want to send out the email notification, and then you want to say, okay, my task is finished. That looks quite simple. But what would happen if that update entity fails? Then you would have already sent out that email notification and the process is not consistent anymore. So what we want to do is we want to hook in the event queue to take care of that transactional safety, of that load balancing stuff. And if we have time, also do a periodic event, for example, do some consistency checks or do some DB health checks, for example. So I brought some commands that I don't need to tip everything. First thing we of course do is install the dependency. Currently we are at version 1.4.6. As already, we can do some configuration. We don't need a config in the beginning. We just have event queue and we want to take over the event queue. The CAP outbox. The CAP outbox is quite similar but does not have that regular periodic job functionality, and also the load balancing stuff is not available with the CAP outbox. So it's similar but it adds features on top. So that means we have here two internal services, the task service, which I configured as an outbox service now. And here we see the features of the event queue. You can specify load, you can specify transaction mode, which is also not available with the CAP outbox, which means when should your transaction be committed. This is quite complicated, but it's described well in the documentation. We have implementation and we have that mail service. So that's all configured here, and we also have configured that the event queue should take over the outbox. I think we have set up most of the stuff. We need to have our email implementation in place. So this is, you can use the event queue as CAP outbox, as I said, but you can also use the event queue way of doing it, so just extending a class. With that you have a lot of more features that are not possible with the CAP outbox. I don't have time to cover that section, but you can do things like clustering events together, for example, sending a clustered email. But it's described in documentation, and We don't have time to follow up on that. And because this is not a CAP outbox service, we need to have a configuration. How is that called? How is the implementation? What's the load? So, and if we now start that project, it boots up, takes some time, initializes the event queue. You don't need to take care or call any function. It's all automatically done because it's a CAP.js plugin, as we heard it already a couple of times. And now we can use, as we have application service, we can use HTTP to do requests to that service. So here I can create a simple task. And then I can also process that task. And as I said, I specified a load of 60%, so it's not possible on one application instance to process 2 tasks at the same time. So that means if I start to process task 1 now and also start to process task 2 now, we see that task 1 is in process, but task 2 cannot be processed now because that application instance has only a load of 100% and 60% is already eaten up. So we need to wait until task 1 is done, and as soon as that is finished, we can process the mail simultaneously with the task 2 because mail takes up, I think, only 10%, and with that 60%, you together at 70%, and you can process both. So this is a lot to take in. I know it's quite packed agenda, but take away that this is doing load balancing, it's persisting events on the database to ensure transactional safety, even though you talk to external services like a mail service, an ABAP system, whatever external BTP service there is, or your service you use for your application. So, what I also want to show is what we can do with periodic events that are executed for each and every tenant regularly. So we can add another section, but here. So here we can define as many periodic events as we want. This has a load of 80%, has a transaction mode, always rollback because we just want to do a DB health check, and it should run every 50 seconds for each and every tenant respecting the load. And of course, we also need to have an implementation for that, because otherwise event queue doesn't know what to do. So we call that event queue DB health check, and then we put the implementation in, really simple. And then we start the server again. And what we will see is that the event queue detects that there is a new event scheduled to be run every 50 seconds. Inserts that event on each and every tenant database. Periodic events are also persistent on the database to be able to communicate between instances and also survive a restart. And now we see that the periodic events are being updated. And now the health check should start to run. We have configured it. Oh, that does not run now. Yeah, unfortunately we don't have the time, but usually that should now run for each and every tenant every 50 seconds. As said, respecting the load, so the events would run sequentially one by one. And because 80% is too much. Okay, that was the live coding session. How much time do we have left? None, I think. Okay. Just want to cover that real quick. Advantages obviously are we can cut business processes in smaller pieces, and then one in each business process can call the next business process. As said, we can build job chains. Those job chains can be tested separately, which I think is quite nice in the unit test and integration test setup. You have the load balancing and load control taken care of for you. There's no noisy neighbor. Should not happen especially if it's our events, you can of course still do it wrong if you do it in another place of the application, but if that is configured well, that should work. You can test remote services, outbox services better because you just need to test that that event is inserted, and then the remote service can be tested differently. And as that event queue provides you with managed transaction as CAP is doing it, so you don't need to take care of the transaction handling, because transaction and handling is always tricky. There are a lot of pitfalls, and I think it's easy to do it wrong, and it will fail eventually, and that pitfall is taken away from you. So thanks for listening to the session. If you have any questions.
So thank you, Max. And for the room, lunch has officially opened. We serve lunch from 12 to 2. But if you postpone your lunch session a little bit and stay with us at 12:10, I promise we will make it worth your time. So for the next session, see you at 12:10 here in this room.